Good morning everyone. My name is Akshara Singh Chauhan. My roll number is 22 and the topic of my presentation is tensors and its types. Superscript and subscript. In the symbol AIJKL, the indices ij written in the upper position are called superscripts and KL written in the lower position are called subscripts. Aij, where ij are superscripts and KL indices are subscripts. Einstein's summation convention. Considering the sum of the series S is equals to a1x1, a2x2, an xn, and by using summation convention, we can drop the sigma sign and write the convention as AIXI. This convention is called Einstein's summation convention and states as if a suffix occurs twice in a term in the lower position and in the upper position, then the suffix implies sum over defined range. And if the range is not given, then assume the range is from 1 to n. Now, what is a dummy index? Index which is represented in a given term is called a dummy index or dummy suffix. It is also called umbral or dextral index. Considering the expression AIXI where I is dummy index, then AIXI is equals to a1x1 plus a2x2 till anxn. Similarly, for AJXJ, it would be the same. So these two equations prove that AIXI is equals to AJXJ. So that means that any dummy index can be replaced by any other index ranging in the same number. Free index. Any index occurring only once in a given term is called a free index. For example, in the expression IJXI, where J is a free index. Kronecker delta. The symbol delta Ij called Kronecker delta, and it is defined by delta superscript I subscript j is equals to 1 when I is equals to j and 0 if I is not equals to j. Similarly, delta ij and delta ij in superscript are defined as follows. It would be the same, 1 for I is equals to j and 0 for I not equals to j. Now scalars. Scalar is a rank 0 tensor. It is an invariant quantity, meaning it remains unchanged under coordinate transformations. And it has no direction, only magnitude. Whereas vectors are rank 1 tensors, they have both magnitude and direction and they transform linearly under coordinate changes. Now what are tensors? So they have both the magnitude and direction, where direction can be 2 or more than 2. In this case, they would be called as tensors. Now, order or rank of a tensor. The rank or order of a tensor refers to the number of indices needed to label its components. It also indicates the dimensionality of relationships. For example, scalar is a rank 0 tensor, vector is the rank 1 tensor, matrix is a rank 2 tensor, and there are higher order tensors with rank 3 plus. Now types of tensors by variance, that means position of indices. The first one is contravariant tensors, where indices are written as superscript like t superscript I and transforms like coordinate vectors. Covariant tensors, where indices written as subscripts t subscript I transforms like basic vector, and mixed tensors where both the superscript and subscript are present Tij and transforms with transformation rules. Now covariant and contravariant vectors of tensors of rank 1. So let x1, x2, xn or x superscript I be coordinates of a point in x coordinate system, and x bar 1, bar 2, x bar n or x bar I be coordinate at the same point in y coordinate system, and let a superscript I, where I is equals to 1 to n, be n functions of coordinates and in x coordinate system, and if the quantities a superscript I are transformed in the y coordinate system, then according to the law of transformation can be written as a bar superscript I is equals to x del x bar I del xj aj, or aj is equals to this. A, I are called components of contravariant vectors. Where A superscript I, where indices is given in the upper position, that means it would showcase the component of contravariant vector. Similarly, in covariant vector, A subscript I, where indices is in the lower position, that means it would give the component of covariant vectors. The contravariant or covariant vector is also called a contravariant or covariant tensor of rank 1. And there is a note given. As we discussed, the superscript is always used to indicate contravariant component, and similarly for the covariant. Contravariant tensor of rank 2 and covariant tensor of rank 2. So let A superscript I, j be n square functions of coordinates x1, x2 to xn in x coordinate system. And if the quantities a, I, j are transformed in y coordinate x bar 1, x bar 2, x bar n, then according to the law of transformation, it can be written as this. And a, I, j are called components of contravariant tensors. Similarly, for covariant tensors of rank 2, it would be the same, where the transformation can be written as this, and a, I, j are called components of covariant tensor. For mixed tensors of rank 2, a, I, j, where I, j is given as 1, 2, n square functions of coordinates x1, x2, xn in x coordinate system, and are transformed in the y coordinate systems, having x bar 1, bar 2, x bar n, then according to the transformation law, it can be written as del x bar I upon into del x l upon del x k del x bar a k l, and where a, I, j are called the components of mixed tensors of rank 2. That is it for the presentation. Thank you very much.